Well, a very happy Wednesday evening to you. We're back. It's an amateur radio class, the beginning class for the technician level? Okay, I'm Gary, your slightly confused instructor tonight, and we're going to do the last chapter in the book tonight, chapter 9, dealing with safety. Then we will take our 5-minute break, get up and move around, and then we'll come back and take a practice test. A 35-question multiple choice test, which is exactly how you get your ham radio license in the United States, by passing a 35-question multiple choice test. And so if you're just tuned into us on YouTube and you go, what the heck is he talking about? This is a whole series, so look for the playlist for the technician class and go back to the beginning, and in order, it'll start to make sense. We use this book, by the way, so if you're going to be looking for the book, it's the American Radio Relay League License Manual for the technician class, the 5th edition. Now, here's something you need to know, though. If you're going to start on this, the question pool in this book is good only through July 1st. At that time, a new question pool will come in. Most of the questions are the same, but some will be altered a little bit to correct language, and some new questions will be added. So this book and this video series is really only good up through July 1st, 2026. And after that, it's good for knowledge. The knowledge is the same, but the actual test questions and answers may change. And we'll have a new class starting in September of 2026. So let's get started tonight. Come on back to the laptop if you would. Hang in there. We're almost done. So ham radio, the whole point of ham radio is it's supposed to be fun. We want you to have fun. And it can be fun to do new and exciting things. And I've been in ham radio for years and years and years, and there are still things that are new to me. Today, for example, I worked an ATNO. What's an ATNO? It's an abbreviation for all-time new one. I worked a station in Macau. There's a DXpedition there going on the air right now, very popular, and I was able to get through on FT8 and make a contact, and that is a new country for me. It's there's all sorts of different ways to have fun, from clubs, from get-togethers, from public service, all of that. But I'll also say that ham radio is not only fun, but it's also an adventure. An unusual and exciting, typically hazardous experience or activity. Gary, this is an adventure. Mountain climbing or hiking in the mountains, that's an adventure. But sitting there with our radios and twiddling knobs, that's an adventure? Well, yes, because in this hobby, there are hazards. And that's what this chapter is all about. But we're going to talk to you about ways to mitigate those hazards with an emphasis, of course, on the test. But I want you to believe that ham radio is an adventure, and we're going to start you on that path tonight. Come back to me just for a second, if you would, Marion. So chapter 9 in this book is safety. In the general class, the next level, chapter 9, there is safety. In the last chapter, chapter 11, in the extra class, it is safety. So we're not going to cover everything tonight. The safety chapters build on each other and add more elements and things. So we're going to be focusing in on what the test questions will be asking you for this chapter. But remember that as you get involved in the hobby, it's a way that you can learn more things. You get a license to learn. And so working with other hams on projects and things like that, you'll also learn a lot of safety tips. So let's go ahead and get started. Section 9.1 is electrical safety. And the first thing we want you to know is that charging lead-acid batteries, these are the batteries that are in your vehicles. If you have a internal combustion engine, you've got a 12-volt battery there. That's a lead-acid battery. And did you know that when you're charging it, the battery releases hydrogen gas? and hydrogen gas is flammable. So they want you to be aware that if you're charging, especially with high currents, that you can generate a lot of flammable hydrogen gas. So that's what they say, no smoking when you're charging or discharging at high current levels. Well, that's not the only hazard from a lead acid storage battery. Mechanics know this one well. If you've got a metal wrench and you've got open terminals on the top of a battery, you do not want to drop that wrench across the terminals. You will be shocked at the flash and bang and fire and smoke because the battery is storing a lot of energy inside of it, and it will release it through a short circuit with the tool that falls across the terminals instantly. And so just make sure you use extra care with metal tools around a battery in a vehicle or elsewhere because you could suffer from burns or a fire or explosion. Now, a 12-volt battery is probably not going to be a shock hazard for you. The rule of thumb is that 30 volts and above could be potentially harmful. 120 volts could be lethal. Both alternating current and direct current circuits. Know that electrical current heats tissue in the human body. That can disrupt cell function, and it can cause muscle contractions that can prevent you from letting go. And to demonstrate that, I would do it, but it's really frowned upon. But back in the day when I was a Boy Scout, my Boy Scout Scoutmaster showed us this trick. You get a hot dog, you put 2 forks in each end of the hot dog, and then you hook it up to a power cable on each end, and you plug it into the wall. And you essentially electrocute the hot dog and cook it. So we did that. That was one of our outings, and we had hot dogs that day. This would be frowned upon today. I don't want you to be the hot dog. So when you're around activated circuits, just be extra special careful. And you would think that everything today, we've got standards, but there are multiple standards. And did you know that the standard for color coding wires, for example, is different between electrical and electronic equipment? In electrical, the outlets in the wall and things like that, they use this color code where black is the hot wire, the one that has the energy, where current is flowing from. The white is the neutral wire where current will return, and the green wire is the safety ground. So black is hot in an electrical circuit in the United States. White is the neutral, and green is a safety ground, an additional grounding element. Whereas in electronics, if you're working on a piece of equipment, generally the red wire will be the hot wire, and the black wire will be the ground or the return. And the other colors will probably be signals that are controls or things like that. So just keep that in mind, that what am I working on now? Am I working on an electrical circuit? Then that's that color code. Am I working on a piece of equipment? Well, it might be a different color code. And with electrical circuits, very popular now, especially in areas where there are damp or plumbing fixtures, things like that, is something called a GFCI, a ground fault circuit interrupter. And the whole point of the ground fault circuit interrupter is the current that flows out of the black wire as it goes through the whatever device it is you're powering, and it comes back to the neutral. The current entering the neutral should be exactly the same. If it is not exactly the same, that suggests to the ground fault circuit interrupter that there's a stray current going somewhere else, maybe through your body. And so, here you are in the kitchen, and you got the toaster plugged in, and you got your hand on the toaster, and you got your hand on the faucet there, and you may provide a path for current. And a good working ground fault circuit interrupter should be able to sense that in milliseconds and open the circuit for life safety. So that's the whole purpose of ground fault circuit interrupters. So you'd think that hams would swear by ground fault circuit interrupters. Actually, sometimes hams swear at ground fault circuit interrupters because especially some that came from Eaton Corporation a while back were known for creating radio frequency interference. They'd be put into a house, and then all of a sudden you'd be listening on the HF bands, and you'd hear a lot of noise, and it was traced to these interrupters. So just, they have good points and bad points. There's a balance in everything. And this is an article from ARRL on that specific problem. So we looked at the safety ground. Remember that green wire? Well, grounding is an issue, or an interesting issue. And there are really 3 different kinds of grounds that amateur radio operators deal with. One is the electrical safety ground. Of course, this is for life safety, protection of property, don't want to cause fires or whatnot. So you want to make sure that you're using properly grounded equipment. And then another type of ground is a lightning protection ground, where you either are trying to dissipate a direct lightning strike, or more likely trying to dissipate static energy from the atmosphere down to the earth so that you don't have a lightning strike at that point. And then amateur radio operators are also interested in radio frequency signal ground. This is the lowest potential that we have for our radio signals, so we want to keep noise and everything off of that potential so that we can hear the weak signals that might be just a little bit above it. So those are the 3 things that hams are interested in with grounding. And for safety ground, 3-wire cords are always recommended. It's this big prong out here that is the safety ground for equipment. This goes to the green wire in the cord and all the way back to the main circuit breaker panel. So 3-wire cords provide you with an AC safety ground. For radio frequency signal ground, we tend to bond our equipment in our ham shacks together when at all possible. They're showing large gauge wire here, but even better is this flat copper strap. You can use braided copper strap indoors, but not outdoors. That's what this mark is here. Outside, you either want to use insulated wire, or you can use flat copper strap. But this will actually corrode outside. And so here we have the grounds for all of the equipment. They're brought to a ground bar here, a single point ground, and that's taken to a ground rod outside the ham shack. So that's for your RF signal ground. Equipment in the ham shack may be powered from 120 volts. It may be powered from 12 volts from a 12-volt power supply. And then if you get a linear power amplifier, especially a tube-type linear power amplifier, built into that is a power supply to take the 120 volts AC up to like 3,000 or 4,000 volts DC. So here's a linear amplifier with the tube inside the tube chimney here. And so this box is specially built. It's got an interlock back here over in the corner, and this is what the switch looks like. This safety interlock is all about life safety. If you pull the cabinet off of this tube-type power amplifier, it will shut off the amplifier in order to keep you from sticking your hands in there and getting a shock or worse. Now, sometimes you do have to work on these amplifiers, and you have to do it in a safe manner. You have to bypass the interlock, but you do that only if you know what you're doing. If you don't know what you're doing, get somebody else qualified to do that. So these are high voltage interlocks. Hams typically see them only in linear power amplifiers like this. Back in Voice of America, where I worked for 20 years on the big transmitters, we had them on all the doors of the transmitters. Come back to me just for a second, Bruce, or Mary Ann, sorry. And so at VOA, we've got these big transmitters. You can walk inside of them. And the thing would be, we'd have, dignitaries or people from Washington come out to the station, and it happened more than once that we'd have somebody from Washington come out and go, "What's inside this door?" They'd open it, pull it open, the interlock would shut the transmitter down, life safety, and of course then we'd have an outage. And we had to close the door, we had to re-energize the transmitter and put our programming back on the air. Thanks. So, but safety interlocks, they're a very, very good thing. One of the grounds I mentioned was lightning protection. And it's not so common anymore, but I remember on my grandmother's house in Auburn, Michigan, where they had lightning rods on the ends of each of the house. And they were there for static dissipation. So for lightning protection, come on back, we want the lightning rod to be up there with a very sharp point at the end, connected to a really high gauge wire, and coming down to a ground rod, an 8-foot ground rod buried in the soil. For lightning rods, you want connections to be as short and direct as possible, and you want to avoid sharp bends in the cable. And the reason for that is plasma energy. If you were to get a lightning strike, plasma energy has a slight amount of mass. And if you have a right angle, it can actually just fly right off the end of the right angle and into something, your car or your TV or something. So you want to make sure that you avoid sharp bends. And lightning paths, can come, from a lot of different places. The house, okay, that's one, but more likely from the power line itself. If they get hit by lightning, you're going to have problems with surges coming into the house. I always had problems with my DSL telephone connection from AT&T at my old house. Anytime a thunderstorm would roll in, I'd be listening to the DSL modem, and yet sure enough, I'd hear a zzz, and I'd know, okay, it's done. Time to call AT&T, and they'd have to come out and replace it. They had lightning arresters and the things on the house. They were doing their best, but it caused lots of problems. Lightning arresters are useful also for ham radio antenna lines going out to the various antennas. And so here are some various styles where you've got a goes inna and a goes outa, and this is mounted on a ground panel. You can see here, well, you want the ground panel to be here's copper strap, flat copper strap, and it's on the outside wall. You want to keep lightning and surges outside if you can, connected to ground rods, multiple ground rods if you can. This is a way that you can avoid having lightning surges damage equipment. Think you're going to put up a tower? If you do, then you want to be considering tower grounding. The rule of thumb is that you want an 8-foot ground rod for each tower leg. So if I look here, this has got 1 leg, 2 legs, 3 legs. Well, they've actually got 4 ground rods. They've got 2 for that one, 1 for that one, and 1 for that one. And they're ground rods at all 4 corners, and they're connected together with very large copper wire underneath the ground here. And this gives a grounding ring. They're bonded together with mechanical connections. You, again, want to avoid sharp corners to be as short and direct as possible for the grounding to be effective. Back in the day when I got started, homebrew equipment that you would build and put on the air yourself was very common, and it's still something that we can do to this day. If you're going to be building your own equipment, especially if it's going to be plugged into the wall, well, make sure that you have fuses for your AC powered equipment, and the fuse should be rated at just above what you think the device is going to be using. So if you think the device is going to be drawing 2 amps of current, maybe a 3 amp fuse would be appropriate. And you want the fuse to be in the hot leg, the black wire. Fuses in the neutral side are not good for life safety protection. So a fuse should be rated appropriately and should be in the hot lead or in the black wire. And if you are going to be connected to 120 volts AC, you're probably going to rectify it and filter it and regulate it for maybe DC use. Well, inside the DC portion of the power supply are going to be charged capacitors. These are really big oil-filled capacitors, and these are probably for a high voltage section of a device. But energy can be stored in the capacitors, much like a battery. And so even if you turn the equipment off, there can be energy inside the capacitor. Come on back to me just for a second. So I had the opportunity to learn electronics in high school. And okay, high school kids, capacitors. We had high voltage power supplies, Hickok 400 volt power supplies that we had in our labs. And it was a real fun thing to get one of these capacitors, hook it up to the power supply, charge the capacitor up, and then throw it to somebody and say, "Here, catch." Take a look at the laptop. There's, yeah, one of those capacitors. And of course, you'd get a shock, or somebody would get a shock, and everybody'd laugh, but you don't want to do that. But that illustrates the point that capacitors can store energy, and you don't want to be the victim. You don't want to be catching one of those. All right, let's answer some questions. Which of the following is a safety hazard of a 12-volt storage battery?
D, delta.
Well, no.
No? Okay.
12-volt batteries probably won't give you an electrical shock because 12 volts is below 30 volts.
A.
It's not A.
Bravo.
Then it would be
Bravo.
It's Bravo. Shorting the terminals. You drop one of those wrenches across the terminals, it will cause burns, fire, or an explosion. RF emissions from a nearby transmitter can cause the electrolyte to emit poison gas. No, that's not true. The battery will be unaffected by RF emissions. So B is the answer here. What health hazard is presented by electrical current flowing through the body?
Delta.
So it may cause injury by heating tissue, yes. It may disrupt the electrical functions of cells, yes. And it may cause involuntary muscle contractions, so indeed all of the above. Yep. In the United States, what circuit does black wire insulation indicate in a 3-wire 120-volt cable?
B. B.
Yep, black is the hot wire. What is a good way to guard against electrical shock at your station?
Delta.
Yeah, all of these use 3-wire cords, connect all AC powered station equipment to a common safety ground, and install mechanical interlocks in high voltage circuits. So all of those choices are correct. Where should a lightning arrestor be installed in a coaxial feed line?
Delta.
On a grounded panel outside, near where the feed lines enter the building. And where should a fuse or circuit breaker be installed in a 120-volt AC powered circuit?
Hello.
Charlie.
Not Charlie.
Alpha.
In series, yes, you want it to open up and then block the current. So it's in series, and you want it with the hot conductor only. And what should be done to all external ground rods or earth connections?
Charlie.
They should be bonded together with either heavy wire, heavy gauge wire, or flat copper strap. And what hazard exists in a power supply immediately after turning it off?
D, delta.
Here, catch. Charges stored in filter capacitors. And which of the following is good practice when installing ground wires on a tower for lightning protection?
C, Charlie.
Yes, ensure that connections are short and direct. Which of the following is true when installing grounding conductors used for lightning protection?
Charlie.
Sharp
C, yeah.
bends must be avoided because of that plasma. You want to make sure that it goes to the ground rod. So which of the following establishes grounding requirements for an amateur radio tower or antenna? What do you think?
I would say D. Bravo.
And you would be correct. Local electrical codes are what you have to go by. So, the book can tell you a bunch of things, but make sure that, you've consulted the local electrical codes used in your area. All right? Section 9.2, managing radio frequency energy in your station. Come back to me just for a second. So, radio frequency signals are a little different than, DC or audio signals or low frequency signals like 60 hertz power. Copper wire is a good conductor of electrical energy. And so at the DC or lower frequencies, the copper wire, all of the copper wire is being used to conduct energy. At RF, that's not the case. At RF, because of the fields that are being built up, the center part of the wire is actually not conducting RF current because of something called skin effect. Come on back, if you would. So on skin effect, so here we're looking at a cross section of the wire, RF current flows on the outside of the wire, just on the surface of the wire. On the inner part here, there's very little current, and it varies with frequency, but the higher in frequency you go, the more the skin effect takes place. And a microwave, for example, there's nothing there in the middle, which is one reason why, for grounding and bonding, flat copper strap is preferred, because there's very little inside and there's a lot of surface area for RF current to conduct through. There's very also little inductive reactance with flat copper strap. So flat copper strap is the best conductor for radio frequency grounding because of the surface area. All right, moving on to something a little different. You've all been in the, high school gymnasium with a basketball game, and there's the PA system. We talked about this when we were talking about oscillators, and somebody turns the mic gain up too high and you get oscillation. That's feedback. That's audio feedback. Well, with radio frequency energy, you can also get RF to feed back into your microphone. Okay, you've got a transmitter. It's going through, an antenna transmission line out to an antenna that may be even, 100 feet away, from your ham shack, but you're radiating energy, and that energy that's being radiated can also be picked up by the electronics associated with your microphone. This is known as RF feedback. And it can happen with single sideband transmitters. It can also happen with FM transmitters. And the result of RF feedback is garbled speech. That's really what you'll sound like. And you'll hear people say, hey, you've got RF in your microphone. That's what they're talking about. They're talking about RF feedback coming back into the microphone and causing this strange garbling of your speech. Now, one way you can cure that, or at least minimize it, is the use of ferrite materials. There are ferrite clamp-on devices that you can put on the outside of cables. Here's one that you can put on the outside of the wire. These actually add inductance and impede the flow of radio frequency current, so then can minimize the effects of RF feedback. There are some other techniques as well, which we'll talk about in the general class and the extra class. Oh, look.
Gary, can I ask a quick question?
You sure can.
that last slide, I've seen some of those, but the wire's looped around, like in a loop around it and then back through it again.
Yes. So, and coming back to me for a second, I wish I had some up here, but yeah, so what you saw there with it going through once, that's one turn through a ferrite. But you can get multiplication of that effect by actually, if you've got a donut-shaped toroid, ferrite toroid, take it through and go 1, 2, 3, 4, 5. Well, you've actually multiplied the inductance that is being in blocking current, and that can be even more effective. So yeah, but they're both effective, but the through the toroid is probably even more effective. And if you come to my house, I'll show you. I got toroids everywhere, doing exactly that. All right, let's answer some questions. Which of the following conductors is preferred for bonding at RF?
D.
That flat copper strap, because of its surface area and because of its low inductive reactance. And what is a symptom of RF feedback in a transmitter or transceiver? What do you say? Charlie, yes. Reports of garbled, distorted, or unintelligible voice transmissions. Yeah, that's what it is. All right. Hey, section 9.3, radio frequency interference. So we're going to start out by talking about interference to others from your transmitter. So here's a tip for you. If you get your ham license and you're going to put an antenna up outside, put the antenna up, but don't hook it up to the transmitter for a day or 2 or 3. It used to be the case that the neighbor would come knocking on the door. I see you put up an antenna. You're interfering with my TV. Well, it couldn't be because the radio's still in the box over there. That's always a good one. But the first question to be answered, though, if you get that knock on the door and say, hey, you're interfering with my TV, ask what channel, and then go to your TV, turn it to the same channel, and see if your own equipment is being interfered with. That's a clue. If you can see the interference on your own TV, then maybe you've got to look at some of your transmission equipment. Maybe something's happening that is causing a problem that's common to both. If your equipment is clean, then there's probably a problem with the neighbors, and I'll show you what the problem is more than likely coming up here as we proceed through. So the causes of interference to others could be the transmitter is generating harmonics on multiples of the fundamental frequency, or it can be just generating spurious emissions. Some inexpensive transmitters will do this. The inexpensive Baofeng transmitters on 2 meters are known for this. Or there's something called fundamental overload. And that's a function more of the receiver than the transmitter. If you've got harmonic output or things like that, you can actually run the output of your transmitter through something called a low-pass filter. Here's one from MFJ that has a 30 megahertz top frequency, which that'll eliminate any interference to television frequencies, for example. So low-pass filters, you'll see them at Hamfests, and they can be a good addition to your system if necessary. Now, the last thing I talked about here, fundamental overload, that has to do with the receiver that's being involved. And if your neighbor's radio is being interfered with, for example, and he's got a cheap Chinese radio or, just $7 radio or whatever, there's no front-end filtering in the radio. They can't reject strong nearby signals, even on different frequencies. So that's something that you might have to help him get a new, better radio that is able to handle fundamental. Yeah.
But this is only anybody who uses a TV with an antenna, a typical antenna. This would be an issue with people who use a typical old-fashioned TV with antennas.
Yeah.
Okay. Because I do
Yeah, yeah. Well, and internet and digital signals can be interfered with, but it's less likely. The old analog TV could be interfered with easily. The off-the-air TV signals still can have some interference as well. But I'll show you coming up here what the main problem is going to be always, and you can be a hero. You can fix the problem. But just know about fundamental overload that has to do with receivers that just don't have any filtering. Now, who has a landline telephone anymore? Well, there's still questions on the test, but if you have telephone interference with a landline telephone, there are filters that you can install on the phone line that can help minimize that. If your neighbor's TV has got interference, one thing that you could try is they make TV interference filters as well that will pass the frequencies, the UHF frequencies that the new modern HD TV signals operate on, but will block lower frequencies. So that's the help. But okay, you ready? This is worth the entire course, the cost of the course. Oh wait, the course was free. Oh, but anyway, bad reception at your neighbor's house is more than likely due to a bad F connector. These things are notorious for corroding. Moisture gets in them. They're not tightened down properly. The inner conductor maybe is shorting against the case. Bad F connectors are the #1 cause of interference problems, and so that's where you want to start. Even with cable TV, they still use these F connectors, and they can be problematic. That's when I had a problem with Charter here. I have Spectrum Internet. I don't have TV with them, but I have Internet. And the first thing he did when he came out was replace all of the cables. He looked at them and said, "These are old. They're gone," and because they know this is the #1 cause of issues. All right, we talked about interference to someone else. Now, what about interference to you? Let's say you look and you hear noise on your radio and you realize every time my neighbor's garage door goes up, I get this horrendous noise in my radio. So what you want to do is work with your neighbor to identify the offending device, politely inform your neighbor about the rules that prohibit the use of devices that cause interference, and then check your station and make sure that it meets the standards of good amateur practice. Just double check, make sure that everything on your side is okay. A lot of devices are being sold under Part 15 of the FCC rules. Garage door openers, baby monitors, things like that. These are unlicensed devices that emit radio frequency energy. And theoretically, they're tested and they meet specifications, but sometimes they're notorious for causing interference issues. And so if you can identify that, as amateur radio operators, we're part of a licensed radio service. And as such, we are protected to some extent from interference, certainly interference from an unlicensed device. And so the law is on your side. They really have to fix it or eliminate it entirely because you're being interfered with. Now, sometimes the interference is something that you really can't do anything about. Let's say you're near an FM broadcaster in your area, and your radios are suffering from fundamental overload from this high-powered FM transmitter near you. You may need to install something called a band stop filter inside your radio in the receive path. This is one for FM, for example. It will block FM signals in the 100 megahertz range from interfering with signals going on in your receiver. And just know about filters, in this case a band stop filter that can be added to eliminate it. You don't want to put it in the transmit path. It's not designed to handle transmit power, but if you can open the radio up and put it in the receive path, then that'll help you out. And when you're putting wire in your ham shack and you're hooking it up, shielded wire is always best because it prevents signal intrusion into or from the cable. The shielding prevents radiation of signals to and from. All right, more questions? Which of the following is a reason to use shielded cable or shielded wire?
Alpha. No.
Charlie.
Yeah, it is Charlie. I heard of some, but it was not distinct. To prevent coupling of unwanted signals to or from the wire. And what would cause a broadcast AM or FM radio to receive an amateur radio transmission unintentionally?
Alpha.
The receiver is unable to reject strong signals outside the AM or FM band. Fundamental overload. I'm looking over here at my YouTube monitor over here, and it's circling the wagon. It's lost me at the F connector, but okay. Which of the following can cause radio frequency interference? Read carefully.
Bravo.
D, Delta.
Yeah, fundamental overload or harmonics or spurious emissions, all of those could cause radio frequency interference. And which of the following could you use to cure distorted audio caused by RF current on the shield of a microphone cable?
D, Delta.
Delta, the ferrite chokes. We say ferrites are your friend. And how can fundamental overload of non-amateur radio or TV receivers by an amateur signal be reduced or eliminated?
Bravo.
Not Bravo.
Not Bravo. Gotta be Alpha.
No, the filters are most effective if you put them on the receive device, the affected receiver. You can put harmonic filters on the transmitter, and so maybe this is a bad question, but the right answer they want you to know about is to put it, and this assumes that the device has an external antenna input. If the antenna is built into the device, well, that's probably not going to help, but this is what they're looking for. Block the amateur signal with a filter at the antenna input of the affected receiver. And which of the following actions should you take if a neighbor tells you that your station's transmissions are interfering with their radio or TV?
Oh, Charlie.
Alpha.
It is Alpha. Make sure your station is functioning properly, check it over, and that it does not cause interference to your own radio or TV when tuned to the same channel. C, a harmonic doubler, that's nonsense. There's no such thing, so don't worry about that. So which of the following can reduce overload of a VHF transceiver by a nearby commercial FM station?
Delta.
That's where you actually have to open the radio up, find out where the receive path is, and install a band reject, also known as a band stop filter. That's yes, it's designed to block the FM frequency range, the broadcast FM range. Okay, so what should you do if something in a neighbor's home is causing harmful interference to you?
D,
Delta.
Yeah, work with your neighbor to identify the offending device. Politely inform your neighbor that the FCC rules prohibit the use of these devices. Make sure your station meets the standards of good amateur practice. So all of these choices are correct. And what should be the first step to resolve non-fiber optic cable TV interference caused by your amateur radio transmission?
Delta.
Yeah, the F connectors. Be sure that all TV feed line coaxial connectors are installed properly. All right, RF exposure, exposure to radio frequency energy. So I like to think about the old 100-watt light bulbs. You can't use LED bulbs, but the old 100-watt incandescent light bulbs, you know, we had them, you know, screwed in there, and we turn them on, and we have, you know, light in our living room, everything's fine. But you learned that the closer and closer that you moved your hand to that light bulb, the hotter and hotter your hand got. And if you put your hand right on the light bulb, oh, you could burn your hand because those 100-watt bulbs got pretty hot. So the same thing applies with your transmitter going to an antenna. And the antenna, think of that as the light bulb, which is, in the case of the light bulb, it's radiating light. In the case of our antennas, it's radiating radio frequency energy. And that radio frequency energy we can't see with our eyes, but it's happening. But the human body can absorb some of this radio frequency energy. And the ability of our body to absorb that energy varies with the frequency. So you'll see in your book on page 9-12 this chart, which is the standard. It has power density over here on the vertical scale and frequency on the horizontal scale. And these are the permitted levels for either controlled or uncontrolled areas. We'll talk about that in a second. But you see they track along with each other. And the human body is most sensitive to radio frequency energy in this frequency range. VHF, 30 to 300 megahertz. Or we would say for the amateurs, the 6 meter and the 2 meter bands, 50 megahertz and 144 megahertz, are the frequency bands that we have to be most concerned about. But we have to be concerned about it for all of the frequency bands, making sure that people can't be injured by our radio frequency transmissions. And so it's required now from all amateur stations to evaluate your station. And it's not that hard, so don't get freaked out about it. There are 3 ways that you can do it. By calculation based on the FCC Office of Engineering Technology Bulletin 65. I know of no one who does it that way. By calculation based on computer modeling. That's the typical way that amateur radio operators do it. And then by measurement of field strength using calibrated equipment. Maybe your local amateur radio club has a calibrated field strength meter and matching antenna, and you could use that to actually make direct measurements. This is the FCC OET Bulletin 65. There's a URL down there. You can find it. And inside, oh, look at this chart. It's the same as we have in our book. And the used to be that if you operated with power levels under these, at these frequencies, you didn't have to do an evaluation. That's not the case anymore. But it shows you that for VHF, 50 watts, whereas for HF, we could go up to 500 watts, or even higher. We could go, in frequency UHF, we could go to 250 watts and still be considered safe. Now you have to do RF evaluations on all stations for all frequencies. Now, it doesn't have to be a formal written report. It can just be a notation in your file that an evaluation was conducted and by what method. And if you use an online calculator, what I would say is print out the results, put them in a file folder, and that constitutes your evaluation. Well, how am I going to do that? Isn't that going to cost me a lot of money? No, there are 3 places I can send you. Here's the American Radio Relay League's RF exposure calculator. And you can use this. You put in information about your station, the antennas, the power levels, the frequency ranges that you're going to be operating, and it'll tell you, are you going to be okay or not okay? You can go to HintLink. Here they have also their RF exposure calculator. Looks a little different, but works on the same principle. And then the Lake Washington Ham Club has theirs as well. So these are the 3 that I know are current. I checked the URLs, and they're all working this morning. So all of these are possible for you to use to evaluate your station. And when should you evaluate? Well, when you're first establishing a station. so that you know things are okay. And then when any changes are made to the station, say changes to antenna or increases in power level, then you might need to reevaluate then as well. And like the light bulb, if you're further away from it, the radiation is less. So time, distance, and shielding, this is the same thing that for nuclear physics and radioactivity, you want to reduce exposure time, move antennas away from people, or limit access. Well, how do you limit access? So it could be as simple as putting a fence around a vertical antenna, for example, keeping people away from it. You certainly don't want people to be putting their hands or their arms or anywhere near the antenna when it's transmitting, because you might get an RF burn. Sorry if I gross you out here, but radio frequency burns, in my experience, are the most painful type of burn you can get, and they're long lasting. It takes a long time to heal, and so you don't want to touch an active antenna. If you ever had that thought, wonder what it feels like, don't, because you won't do it again. Radiation safety can be as simple as making sure, if you've got a nearby neighbor, really near, that the antenna doesn't point in their direction. You can actually put stops on antenna rotors so that you will never point the main beam in that direction. Note that I talked about radioactivity. Radio frequency energy is what we call non-ionizing radiation. On frequencies that are below the frequency of light, those are non-ionizing. They don't cause chromosomal damage to human cells and things like that. Whereas radioactivity, it's above the frequency of light, that does ionize, and that does cause chromosomal damage to human tissue. So they're both radiation, but they're entirely different. But the same kind of rules of physics apply. If you're double the distance away from something, the factor, it goes down by a factor of 4. The square law rule. So distance, shielding, and time are all the things that we want to do. And remember that light is the border between ionizing and non-ionizing radiation. Another thing that we can keep in mind, because I said time is another factor, well, we don't transmit 100% of the time. Broadcasters do. They transmit 100% of the time. So they have a 100% duty cycle. But as amateur radio operators, we're listening as much as we're transmitting, probably more. And so our duty cycle is going to be less than 100%. Also, the modes of operation we use are not going to be full power modes necessarily. And so for single sideband, for example, and CW, we consider that mode level less than 100%. 50%, and then we're receiving. So you can always consider your transmit and receive times and the modes that you're operating when you're calculating these things, and then the computer models will take that into effect. It comes into play with that graph that we looked at before. If the duty cycle is 50%, then you can double those limits. So if the transmitter's duty cycle is 50%, then the allowable power density can be doubled. And if you'd like to put up a controlled area, this is where people are informed that radio frequency energy is possible in your area. It can be as easy as a sign, not the sign on the left. That's the one for nuclear energy, but the sign on the right, that one is for radio frequency radiation hazards. You can get these signs on Amazon. That's where I got mine. And make your site a controlled area. Put up the signs near where your antennas are located so that you inform people that there is a radio frequency hazard, and that also then allows you to use the controlled levels, the higher levels, when you're doing your evaluations. Questions? What type of radiation are radio signals? Non-ionizing. And at which of the following frequencies does maximum permissible exposure have the lowest value?
Bravo.
We said it was VHF, so 6 meters and 2 meters, so 50 megahertz is 6 meters. And how does the allowable power density for RF safety change if the duty cycle changes from 100% to 50%?
Charlie.
It increases by a factor of 2. And what factors affect the RF exposure of people near an amateur station antenna?
Delta.
Yes, somebody's talking, but their microphone's not picking you up. But yeah, it is delta.
Delta.
Frequency and power level of the RF field, distance from the antenna to the person, and radiation pattern of the antenna. All of those are correct. And so why do exposure limits vary with frequency?
Delta?
Delta.
Yeah, the human body absorbs more RF energy at some frequencies than at others. And which of the following is an acceptable method to determine whether your station complies with FCC RF exposure regulations?
Delta.
By calculation based on FCC OET Bulletin 65, by using computer modeling, or by measurement of field strength using calibrated equipment, all of those are correct. And what hazard is created by touching an antenna during a transmission?
Burn? You
That,
burn.
that ugly RF burn to the skin.
I saw that picture.
Yeah.
You know, I almost did that, sir.
Yeah,
I
don't-
know I can't do that.
Yeah, don't do that. You'll only do it once.
I want.
So which of the following actions can reduce exposure to RF radiation?
Alpha.
If you saw you're going to have a problem when you do the calculations, if you relocate the antennas to a different location, you might be able to then continue. Relocating the transmitter won't do anything. Increasing the duty cycle certainly won't do anything. But relocate the antennas.
It has to be the actual source.
Exactly. That's right. How can you make sure your station stays in compliance with RF safety regulations?
Bravo.
Yep, by reevaluating whenever an item in the transmitter or antenna system is changed. And why is duty cycle one of the factors used to determine safe RF radiation exposure levels?
Alpha.
It's not D, it's A. You got it. Yeah, it affects the average exposure. It allows you to have a double the limits. All right. What is the definition of duty cycle during the averaging time for RF exposure? What are we concerned about?
Charlie.
We don't care how often we're receiving. We want to know how the percentage of time that a transmitter is transmitting, the amount of time that it's radiating RF energy. And how does RF radiation differ from ionizing radiation?
Alpha.
Yeah, RF radiation does not have sufficient energy to cause chemical changes or damage chromosomes' DNA. So who is responsible for ensuring that no person is exposed to RF energy above the FCC exposure limits?
Bravo.
Yeah, the station licensee, that's you. You're responsible. All right, mechanical safety, this is the last section. So you may have an antenna tower in your future. If you do, and you want to put it up, make sure that you get training. There are actually courses that you can take to tower climb and to learn safe operating procedures. Hard hats and safety glasses should be worn at all times. You want to make sure that you're always tied off to the tower. You're using a safety harness that is rated for your weight and also that is within its lifespan. They actually age out and they're not safe anymore. And so with lanyards that are connected to your safety harness, you always have one of them connected to the tower. Then you take another one off and move it up higher. That's how you can climb. The two-man rule, this is something we had in VOA. Whenever you're doing electrical or mechanical work at height, you always have to have two people there. If for no other reason for somebody to call 911. And obviously, avoid electrical lines. Come back to me just for a second, if you would, Marion. Avoiding electrical lines. I've had a wonderful career. I worked for the Voice of America for 20 years, but before that, I worked in commercial television up in Michigan, and as a maintenance engineer. And we got the duty that we would take the live truck out to where the TV station was going to have a live shot, and we'd set up the microwave tower or a pneumatic tower that would raise up out of the van. And on the controls of the live truck, no joke, we had a sign up above it. And the sign said, "Look up, stupid." The whole point was that mast, as it's raising up, you don't want to get it touching electrical lines like this guy did. See the electrical lines here? They're going to go along here. They raised the mast. That's smoke, soot, ash. They melted the tires on the truck. So same thing applies when you're putting up antennas in amateur radio. Look up, stupid. Make sure that electrical wires aren't there. Also, if you're going to have a tilt-over tower or a tower of any kind, it's the 10-foot rule. You want to make sure that you're at least the height of the tower plus 10 feet away from any power lines. You do not want to erect a tower adjacent to power lines, because if it falls to the power lines, that's no good. That's a problem. And also, this is a crank-up tower, so you see it's nested down here, and then you tilt over, and then you can tilt it up, and then you can raise this up. You cannot climb crank-up towers unless they are mechanically blocked or if they're retracted. Because the problem is it's kind of like a guillotine. There's aviation cable in there, and if the cable were to snap, that can cause all sorts of problems. So you don't want to climb crank-up towers until they're mechanically blocked, or if they're retracted, then you can do it. And well, how do you get an antenna up one of these towers? Just included, this is not part of the test, but gin poles are used. I think it comes from Genie. It's a thing that clamps to the side of the tower, and it's got a block up here that a rope or a cable can go through, and you use it to lift tower sections up and then swing it over and put it on top, and that's how they build towers vertically, one section at a time. And probably you're going to be guying this tower. You're going to run guy wires down to anchors down below. Here are the guy wires, for example, on this tower. And most of the time you'll be using turnbuckles at the base, which you can then rotate these and tighten and tension the guy wires so that they're properly tensioned. One thing though, vibration in the guy wires can cause these turnbuckles to loosen. So if you are using turnbuckles, you always want to add a wire through the turnbuckle in such a way that it prevents it from rotating, so that it doesn't loosen up on you and cause an issue that might cause the tower to come down. And no, other than Marion, who got a free pole from the power company, we just heard about this before, you are not allowed to mount an antenna on an active utility pole because you get a high zap potential. They actually retired a pole for him and gave it to him, and he put his Higgs beam on top of it, but no energy. It's not energized. All right.
Well, thank you for letting me know that. I was thinking about that.
Yeah. No. All right. So what is required when climbing an antenna tower? All of those, yes. Have sufficient training. Help other people put up towers and get some training. Use appropriate tie-offs at the tower, the lanyards on the tower all the time, and wear an approved climbing harness rated for your weight and within its lifespan. I think they're good for typically about 8 years. And under what circumstances is it safe to climb a tower without a helper or observer?
Never.
Never. Two-man rule. And which of the following is an important safety precaution to observe when putting up an antenna tower?
Charlie.
Look up, stupid. Look for and stay clear of any overhead electrical wires. And what is the purpose of a safety wire through a turnbuckle used to tension guy wires?
Keep it from turning loose.
That's right, to prevent loosening of the turnbuckle from vibration. And what is the minimum safe distance from a power line to allow when installing an antenna?
D. Yep.
The 10-foot rule. Enough so that if the antenna falls, no part of it can come closer than 10 feet to the power wires. And which of the following is an important safety rule to remember when using a crank-up tower?
Charlie.
Yep, this type of tower must not be climbed unless it's retracted or you have mechanical locking devices that have been installed to prevent it from coming down. Which is a proper grounding method for a tower?
Delta.
Separate 8-foot ground rods for each tower leg bonded to the tower and to each other. We saw that earlier.
Right.
And why should you avoid attaching an antenna to a utility pole? I say high ZEP potential. Yeah, the antenna could contact high voltage power lines, so don't do that. And ladies and gentlemen, we made it to the end of chapter 9. That is it for the instructional portion of the class. I'm so proud of you. Come on back to me just for a second, Marian. When you first saw the book and you looked at the material, you went, huh? Well, hopefully you've got a little better understanding and things have come clear. Even if things are still a little murky, that's okay. But continue to study, continue to practice, and we'll make sure that you pass your test upcoming.
Can I ask you a question?
Sure.
Yeah, I'm setting up a 40-foot antenna at this time, but it's going to be for GMI purposes, not yet 10.
Yeah.
But it's going to be the same setup, right?
Yeah.
I'm using, my essential one is I'm using a default bucket with
Yeah.
cement and a 4x4 12 feet wooden, then I have the mast. It's the one that the cable satellite company uses.
Yeah.
And then on that mast, I'm putting in a telescopic pole,
Right.
and then which elevates, to 24 foot. So altogether it's going to be about 6-7 feet high, but I'm using just a small GMS antenna that
Right.
works for both 7 meters, both for ham and GMS frequency.
Right.
With that little
That small UHF antenna. Yeah.
yeah, exactly. So, we're going to be putting next to me, approximately 1.5, 15 feet away, right? There's going to be an adjacent property where there's a baby. Okay? So my question to you is, it's going to be basically 40 feet high. Would that
Right.
be a hazard for them?
Probably not. If the baby's going to be at ground level and the antenna is going to be up, you might go to one of those websites and put in a UHF frequency because the GMRS is UHF generally, and see what it tells you there. But I think you'd be fine because your power levels are going to be.
It's not high. Right here where I live, most of the trees, they go up because it's an old town here in Lakeland, Florida.
Yeah.
Where Lakeland, Florida is, where I live.
Yep.
So all of those trees branch about 50 feet high, my goodness. So, that's about as high as I can get it safely with that conversion to the stopping pole,
Yeah.
to the mast, and the 12-foot 4x4 DD battery, right?
I'm glad you're thinking about it. Yeah, I'm glad you're thinking about it. But yeah, I think you should be okay because 5 watts GMRS frequencies up at UHF, I think you should be just fine. And yes, I know Lakeland, Florida, the summer home of the Detroit Tigers.
Sir. Thank you, guys.
All right, let's get up and move around. Let's take 5 minutes. We'll have an intermission. Then I want you to come back with pen and paper, please, or pencil and paper, and we'll take a complete 35-question practice test next. All right, see you in 5. welcome back. Hope you got a chance to move around and get refreshed a little bit. Strong suggestion for you. Find a good local ham club. Go ahead and take the laptop if you would. Here's the URL from the American Radio Relay League's Find a Club page, and you can put in your zip code and find an affiliated club there. When you get your ham license, and you will get it, it's a license to learn, and you'll learn a lot more by joining a club, finding other like-minded people, and members there can help you on your path. So, all right, tonight we're going to take a 35-question multiple-choice test. It's an actual practice test. This is practice test 18. What? We haven't taken any practice tests yet. Well, actually, we've been teaching this class from this question pool for a number of years now, and so we're up to practice test 18. If you look in the folder for the handouts for tonight, you will find practice tests 1 through 17 are already there as PDFs. And so you can use those to take practice tests. I want you to take 15, 20 tests. And that'll get you comfortable with the material and give you a chance to see most of the questions. We produce the exam you're going to take tonight using the American Radio Relay League's exam review website. And you can also go there and take practice tests at any time. Highly recommended. So what we want you to do is get out a blank sheet of paper, please, and we'll be numbering it 1 through 35. You can number it as we go. And write down A, B, C, or D, whatever you think the right answer is. Just remember, these are the actual questions and the actual answers that you would see on a test, but the answers won't be in the same order. So don't memorize A, B, C, or D. That'll get you nowhere. Because they will confuse you for sure. But just know what the right answer is, and I want to wish you the best of luck. I'm not going to read the questions. Oh, and for those of you who are going to be taking the test and you have your cameras on, when you're done with a question, if you just raise your hand, then I can tell I can move on to the next question, and we can go back to any question before we find the answers. And we're kind of moving along at a regular pace here tonight. Know that at your test session, you'll have as much time as you need, that you won't be rushed at all. So here is question number 1, and just let me know if you can't read anything, and I won't read the question and answer here, though when we get to the answers, I will, for those who might be visually impaired. So here is question 1. All right, and question 2. All right, if I go too fast, just let me know. Question 3. And question 4. And here we go with question 5. And now, question 6. And here is question 7. And now, question 8. And question 9. And question 10 is a schematic, and they're asking, what is component number 3? And here is question 11. And question 12. And question 13. Next up is question 14. Give you some extra time to get the calculator out. All right, and question 15. Next up is question 16. And now question 17. And here we go with question 18. And now question 19. And question 20. And question 21. And question 22. And question 23. And question 24. And question 25. Give a little time in case anybody's doing some calculating. And question 26. And question 27. And question 28. And next up, question 29. Question 30. Question 31. And question 32. We can go back to any of these. Question 33. Question 34. And question 35. Are there any questions you'd like me to go back to? You can look at it again. Just unmute and let me know.
Number 17, please, Gary.
You betcha. This is the only way I know how to do it. I have to go back manually. So 17.
Thank you.
Yep. Anything else? Any other questions? Okay, let's see how we did. How did we do? So for question 1, which of the following displays an electrical quantity as a numeric value? That's meter. 1A, a meter. And 2, how should you respond to a station calling CQ? Transmit the other station's call sign followed by your call sign, 2C. 3, who may receive telemetry from a space station? Anyone can receive, 3A. 4, which is equal to 1 kilovolt? That's 1,000 volts, 4C. And 5, what electrical component opposes the flow of current in a DC circuit? That's a resistor, 5D. And 6, what electronic component allows current to flow in only one direction? That's a diode, 6B. And which of the following connections is made between a computer and a transceiver to use computer software when operating digital modes? Well, the only one that makes sense is computer line in to the transceiver's speaker connector. The output of the transceiver audio going to the line in of the computer, 7C. And 8, which of the following is a valid technician class call sign format? KF1XXX, a 2x3, 8D. The others are reserved for extra class. Which of the following is a requirement for the issuance of a club station? The club must have at least 4 members, 9D. In the schematic, what is component 3? That is a lamp, 10A. And 11, which of the following are typical duties of a net control station? To call the net to order and direct communications between stations checking in, 11C. And 12, what does a dummy load consist of? A non-inductive resistor mounted on a heatsink, 12C. And 13, when may an amateur station transmit without a control operator? Never, 13B. And 14, how much power is delivered by a voltage of 12 volts DC and a current of 2.5 amps? That's 30 watts, 14B. And 15, what is the approximate velocity of a radio wave in free space? 300 million meters per second, 15C. And 16, what would cause your FM transmission audio to be distorted on voice peaks? Well, one thing could be you are talking too loudly, 16B. And 17, which of the following best describes an amateur radio mesh network? That's an amateur radio-based data network using commercial Wi-Fi equipment with modified firmware, 17B. And 18, when is willful interference to other amateur radio stations permitted? At no time, 18D. 19, which of the following actions should you take if a neighbor tells you that your station's transmissions are interfering with their radio or TV? B, make sure that your station is functioning properly and that it does not cause interference to your own radio or TV when it's tuned to the same channel, 19B. And 20, what is the voltage across a 10 ohm resistor if a current of 2 amps flows through it? 10 times 2 is 20, 20D. And 21, under what conditions is an amateur station authorized to transmit music? D, when incidental to authorized retransmission of manned spacecraft communications, 21D, a really old rule. And 22, what is the advantage of having multiple receive bandwidth choices on a multi-mode transceiver? It permits noise or interference reduction by selecting a bandwidth matching the mode, 22D. And 23, which of the following is an acceptable method to determine whether your station complies with FCC RF exposure regulations? All 3 of those, measurement using calibrated equipment, computer modeling, or the OET Bulletin 65 procedures, so 23A. And which term describes the rate at which electrical energy is used? That's power, 24C. And 25, what is the approximate length in inches of a half wavelength 6-meter dipole antenna? So if it's a half wave, it's going to be 3 meters long, and if you convert 3 meters to inches, 112, 25A. And 26, which of the following is a source of loss in coaxial feed lines? All of those: water intrusion, multiple connectors, or high SWR, sources of loss, 26D. And 27, which of the following is a safety hazard of a 12-volt storage battery? Shorting the terminals can cause burns, fire, or an explosion, 27D. And 28, why is the radio horizon for VHF and UHF signals more distant than the visual? The atmosphere refracts radio waves slightly, 28B. And 29, which of the following describes combining speech with an RF carrier signal? That process is called modulation, 29C. And 30, what is a grid locator? It's a letter number designator assigned to a geographic location, 30C. And 31, which of the following VHF-UHF band segments are limited to CW only? It's the bottom end of the 6 and 2 meter bands, so 50 to 50.1 megahertz and 144 to 144.1 megahertz, 31A. 32, which of the following is an important safety precaution to observe when putting up an antenna tower? Look for and stay clear of any overhead electrical wires. Look up, stupid, 32C. And 33, what is the characteristic appearance of a cold tin lead solder joint? A rough or lumpy surface, 33D. And 34, what effect does multipath propagation have on data transmissions? Error rates are likely to increase, 34C. And finally, which of the following is a form of amplitude modulation? Single sideband, 35B. So the question is, did you have 26 correct? I hope so. No more than 9 wrong answers. If so, you pass. And you can do it. Keep going. And if you enjoyed the class and you'd like to pay it forward, we do accept donations. You can go to my website, w4eey.com, and there in the middle is a PayPal donation link. Let me turn the laser pointer on so you can see that a little better. Right there. And if you don't want to do that, I'm good on QRZ.com, or just email me and I'll give you an address so you can mail me a check. Any monies that you send us would be used for the production of future classes and videos on the channel. Come on back to me. Very good. I am so proud of you. You made it through. The plan is for next week will be our very last class. It's optional to you, but if you want to come back and do practice tests like we just did, we'll have 2 more of those for you next week to get you all geared up and ready to go. Any final comments or questions before we get out of here tonight?
Very instructive, sir.
Very,
Wow. And very impressive. Thank you.
you betcha. You've been a great class. Come on back next week. We'll do some practice tests. Until then, 73, y'all.
73, sir.